Okay, great. So welcome everybody. Good morning, good afternoon, depending on where you're joining us from. Welcome to Best Practices for a Sustainable Mechanical Room. A huge thank you to Scott with Neptune Benson for joining us today. I know sustainability is obviously a very important topic, a very hot topic. So we really appreciated that they came to the table with this topic for all of us today. I know we'll learn a lot. Scott is happy to take questions, so you can either send it in the chat or the Q&A. I'll help him kind of monitor that throughout. We'll have time at the end as well to kind of dive into some of those questions that come in. So with that, welcome, Scott. I'm going to turn it over to you. And yeah, if I can help with anything in the meantime, you let me know.
Thank you, Ann. I really appreciate it. And good morning, good afternoon, everybody. Appreciate the opportunity here to speak with you guys again. It's been about a year since I've have talking to you as a group on one of these webinars. Probably, let's see if we can get the screen going. There we go. As Ann mentioned, my name's Scott Hyland. I'm with Neptune Benson. We're owned by Evoqua Water Technologies. I've been doing this for about 23 years here at Neptune Benson, my entire tenure. I consider it a life sentence, right? I don't plan on going anywhere. Extremely passionate about what I do and the people that I'm fortunate enough to work with. And as I'm sure a lot of you have heard me in the past say, the swim school industry is very passionate to me. What you guys are doing is incredible and really a life lesson that we got to make sure that, the future kids know how to swim because it is the leading cause of death for children today. So we gotta stop that in short. Enough rambling though. As Ann mentioned, I'd be happy to take questions throughout the presentation. Feel free to, put something in the chat. It doesn't need to be just me here talking for the entire time. So I'd love to answer any questions as they come about. Here's a brief agenda, what we plan on touching on today. A brief introduction of who Neptune Benson is. And then we're also going to focus on our Defender regenerative media filter and our wafer UV. On the last webinar we did last December, we really went over how it works, how you utilize the Defender, how the controls work, the valving, the piping, etc. So this time I want to focus more on the operations, maintenance, preventive maintenance. We'll touch on some preventive maintenance and other equipment as well, strainers, sand filters even. So Neptune Benson, established in 1956 by two brothers, Ray and Babe Gertz. They were the sons of Ben, so that's where Benson came from. Neptune's obviously the god of the seas. However, in 1978, back in 1956, it was Benson Engineering and Neptune was making, above ground galvanized swimming pools. But in 1978, there was a devastating fire, burnt the plant down to the ground, and that's when they decided to switch to a focus on commercial filtration. You think back to the early 80s, Disney's Typhoon Lagoon, and those sorts of parks were being built. Back then in the 80s, it was a lot of steel filters, single cell, dual cell, triple cell, even gravity sand filters that, soon became pressure high rate sand filters. Then in 1992, we introduced the horizontal fiberglass sand filter, which majority of the industry is familiar with today. The fiberglass, non-corrosive, sediment, forget them. Pretty simple technology, right? Tank filled with sand, water goes in one end, comes out the other clean. In 2003 is when we introduced the Defender filter, which was really a game changer for the industry. Pools have always been looked at as an expense, a hole in the ground that we're dumping money into. But with the help of Defender, we've really been able to change that so it can be a more sustainable attraction than it once was. In 2012 was a big year. We acquired ETS UV, and we also acquired Lawson Aquatics, which is PVC extruded products, main drains, sumps, grading. And then in 2016, we were acquired by Evoqua Water Technologies. So that was a big move for Neptune from going from a second generation family owned business to part of a big corporation that, a short time later became publicly traded. But it's really a nice fit for Neptune Benson and Evoqua because our focus for the entire company is water, and sustainability is at the top of the list. It is a corporate focus here. Clean, healthy water and sustainability. We actually were awarded the Frost and Sullivan Award this year for sustainability or sustainable products. So pretty exciting for a company as a whole. This is our product portfolio, which a lot of it is sustainable products, from the Defender filter on the left or the UV there in the center of the page. And you can see our sand filters down below the horizontal fiberglass. We still do the steel filters, single cell, dual cell, and triple cell filters. You'd use a dual cell or triple cell if there's a backwash restriction. So reducing the amount of filter area to reduce the amount of volume that's required when you're backwashing the filter. But the cost, the space, etc., there's more realistic options available than those large old steel tanks that we were familiar with back in the 80s. There at the top right of the page is the Lawson Aquatics portfolio. The PVC extruded products, grading, main drains, edge treatments, deck drains. We have a number of, I guess it's important to mention that the Lawson main drains are all up to the current SOFA requirements. As there's life cycles on these grates that need to be replaced, so you should be mindful of when your framing grate was installed at the bottom of your pool, and make sure that it's replaced in the necessary time frame to make sure that you stay VGB compliant. Our accessories are a lot of mechanical components in the mechanical room that complete the system, from the Heron Lynch strainers that protect the pump from debris from damaging the impeller. Our green drive is very sustainable. Green drives, variable frequency drives, they're going to control the speed of the pump, and we'll touch on that in a moment here. But every pump needs a VFD on it. And so that's something you should really look into if you're not utilizing VFDs yet. And as I said, we'll go into in a moment here, just to make sure that we're using them appropriately in the correct way, so that you do get the benefit of what they offer. It's very easy to have a VFD and not utilize it appropriately, so you're not recognizing those substantial cost savings electrically. CO2 feed systems, we have our Dominion valves, which our valves are very nice because it's an aluminum body with a real coated disc. So if you're using larger size valves, they're not heavy, right? They're aluminum body instead of a cast iron. Our reducers are available in stainless steel and fiberglass, just like our Heron Lynch strainers. Those are, making direct connections from the plumbing to a recirculation pump, or maybe a UV system, just connecting the flanges. Our Chem Clean, that can be used on our Defender or any sand filters. It's a degreaser. And our Blue Sentinel is our chemical control line. But as I said, a lot of these products are sustainable, which is our focus. And I just wanted to share where we're at with Defender. Defender came out just 20 years ago. And in that 20 years, we've saved over 1.5 billion gallons of water. That's pretty substantial. So just in 2 decades, we've installed Defender on 6 continents, 54 countries, and there's close to 4,300 installations to date, consistently growing. I can share with you, I'm very excited for the swim schools, and could probably confirm this, but if I'm not mistaken, we joined your industry as a sponsor. I believe it was around 2015. We really saw and I've mentioned this many times, traditionally a swim school, not very big pool, right? Could be the size of a backyard pool, but it's the number of bathers that you're putting through that water that makes you equivalent to like a Disney's Typhoon Lagoon. Massive bather load. So excited to report that in the last 7-8 years, we've installed Defenders on 80 swim schools, many of whom are members of this association. So we really appreciate that, and see the benefit of installing Defender, particularly on swim schools. give you a little insight as to how the Defender is made. Want to stress that this is all made under one roof. This is all manufactured by Neptune Benson of Evoqua Water Technologies. So it comes in as raw steel and it leaves as a finished product like you see there on the right. It is a carbon steel tank, but we line it with that Navajo white colored lining there, which is called Flexol 3000. And that gets applied to all interior wetted surfaces, and it extends right out to the external flange to protect the tank. So we are guaranteeing the tank for 10 years against leaks. We're also guaranteeing, the flex tubes that, here's a flex tube right here at my desk. We guarantee these for 10 years as well. Shouldn't have to replace them ever throughout the life cycle of your filter. And if you ask me a life expectancy, I'd say probably 30, 35 years or more. It really depends on how well you balance your water and you maintain your equipment. If there's a drip overhead that's dripping down on the filter, well, we'll want to fix that drip overhead, right? We don't want to let problems fester. We want to fix them as they arise because they only compound. I also like to just stress our capacity, our capabilities, and how we are vertically integrated. So all the design, engineering, right down to the fabrication and finish is all done by Evoqua personnel. So, a warranty is only as good as the person that writes it. We've been here since 1956. We're going to be here till 2156 or whatever it might be. So we're really here to support our products as they age. And, there's nothing better than somebody coming back to replace our equipment 20, 30 years later. The sustainability aspect of Defender, I often refer to as the Fab Five, the features, advantages, and benefits. There's 5 of them. Compared to typical high rate sand filters, Defender is going to save up to 90% less water and waste versus a sand. This is because we don't backwash it like a high rate sand. We're going to reduce the electrical demand by up to 50%. This is in conjunction with a variable frequency drive. We're going to save up to 30% on fuel and chemicals, up to 75% less in space, and ultimately you're going to get the superior water quality. And I guess I'll digress in a moment. So where are the water and waste savings derived? Well, if you think about how a sand filter backwashes is we're reversing the flow for 3 to 5, maybe even 7 minutes. Every time the pressure differential builds up. So you're sending thousands, if not tens of thousands of gallons of water to waste every time you backwash. If we used a simple example of like a system that's doing 500 gallons a minute, you're going to be backwashing closer to 550. You're always going to backwash at a higher rate than you're filtering. So if we do that for 5 minutes, just 500 times 5, that's 2,500 gallons, right? If we did that once a week, that's 10,000 gallons a month. Whereas a Defender, on the other hand, it regenerates every day, where it releases the perlite from the flex tubes and redistributes it to more open area and maximize its dirt holding capacity. But no water is sent to waste every time we do that every day. And you could even do it 2, 3, 4 times a day. I recommend people bump in the morning before they open up and then bump at night when they shut down so that the system's got capacity to clean up the water for the next day. Typically, if a sand filter's backwashing once a week, the Defender, you're only going to need to drain it about once a month and change the media. So you're only sending the capacity of the tank to waste. So in that same example of 500 gallons a minute, the sand filter is going to backwash 10,000 gallons a month or more. The Defender, changing the media, total volume sent to waste will just be 318 gallons, 2 tank volumes. So a substantially less amount of water sent to waste. So the first response that I get to that, or I shouldn't say the first, but I often get questioned, well, how do you address TDS, right? Because total dissolved solids, the only way to get rid of them is 2 ways: reverse osmosis, which is not an option in aquatics yet, or by fresh makeup water. So how I answer this question is TDS can be an issue. Obviously, more of an issue with Defender because you're not backwashing like you do with a sand filter. However, you should not manage your TDS levels based on your need for backwashing, or you shouldn't what I'm saying there is if your TDS levels are high, well, we shouldn't just go backwash our sand filter. We should only backwash our sand filter if the pressure differential is at that point of requiring a backwash. A dirty filter works better than a clean filter. So if we're going to reduce our TDS levels every time, we go backwash our filter every time we need to decrease our TDS levels, we're not doing our system or our operation any justice. TDS should be managed separately. So how do you do that? There's a number of ways. It could be, and every site is different. It could be something as simple as your sample stream on your chemical controller with a slow drip to waste 24 hours a day. That's creating that demand. The point I just want to get across is that to manage TDS does not require the volume of water we send to waste with a sand backwash. If you're not aware, we do a cost savings analysis that breaks down the operational costs of a Defender versus sand. And when it's an indoor application, we actually take 10% of the projected sand filter backwash and add it to the Defender consumption to take into consideration TDS management. So happy to talk about this topic with anybody in the future or outside of here, but just want to bring that to light. The electrical savings, and as I said, most of this is due to the variable frequency drive. However, the Defender does have less head restriction than a sand filter because a sand filter is depth filtration. Defender is surface filtration, so there's less head restriction. And you can see this on the left axis of the curve here. We've got our PSI to begin with. So typically a Defender only starts out with about a 1 PSI differential from clean or when it's clean, whereas a sand filter, when it starts up, it's about a 5 PSI differential. Well, that equates to about 10 feet less head restriction through a Defender versus sand. So how's the VFD? So that's one, less horsepower, right? Less cost. So that's one savings with the Defender. But the additional area or savings is this yellow area here, because a sand filter, we start with a differential with about 5. And then once you turn it on, it only gets dirty and it peaks out when we reach a 10 to 12 differential. And then we need to backwash and it comes back down. Whereas the Defender, we start off, the filter gets dirty, and then at the end of day one, we bump it. The pressure comes back down. Then it builds, comes back down when we bump it. So every time this drops is when we're seeing a bump on the daily basis. So all this yellow space here is additional cost savings associated with Defender, electrical cost savings versus a sand filter. However, now for my digression from earlier is we need to make sure these VFDs are set up correctly. There's a couple different benefits with a VFD. Well, one, you should contact your local utility provider and see if they're offering any grants for variable frequency drives. Two, we want to make sure that the benefit of a VFD, or one of the benefits, is that the soft start, it takes 30, 45 seconds, whatever you want to program it to ramp up. So if you've got a, say, 15 horsepower pump, we're slowly turning it on to get our desired flow rate. We're not just flipping the switch and going 0 to 60. Because what happens is the electrical company looks at what your peak demand is. They look and see what is the most power you require at any given time, and that's what they're going to charge you for. So if they see a 15 horsepower, 20 horsepower pump turn on, bing, dollar signs start popping out their heads, right? They're seeing, wow, they need all this power. Little do they know, you just need it to start that pump up initially. But if we have a variable frequency drive, which has a soft start, the electric provider is never going to see that peak demand. They'll never see a spike. So that'll bring your overall rates down. But then it's most important that we tie the VFD in with a flow meter on the return line. The flow meter is reading your gallons per minute at any given time. I recommend using a mag meter, which doesn't have anything. It doesn't get fouled like a paddle wheel, right? It's magnetic, so it's a mag meter. It's reading the flow by the magnetic field, going through it. And that's going to be a lot more precise, doesn't get dirty, but you want to tie that in with your VFD with a 4 to 20 milliamp signal. So just two simple wires that go from your flow meter to your VFD. And what that's going to do on a filter, whether it's sand or Defender, is it's going to ramp that pump up and down based on the current head restriction. So if your sand filter is clean, the flow meter is going to tell the VFD, hey, slow down. I don't need so much flow. But as that sand filter or Defender gets dirty, the flow meter is going to be saying, hey, VFD, ramp that pump up. We're not maintaining flow. So it's very important that that's set up correctly in order to recognize all the substantial operational savings. And it's really big. I mean, a VFD should pay for itself in much less than a year. I'd say 10 months. And so it's also benefits still on feature pumps and attraction pumps, anything outside a filter recirculation pump, that's just flowing the continuous flow simply for that soft start feature. The fuel and chemicals, up to 30% in savings. That's associated with the reduction in the amount of water that we're sending into waste and that we got to make up, right? The less water you got to make up is the less water you got to retreat and reheat. Additionally, the Defender has the ability to filter down to 1 micron. So we're removing more organics from the water, allowing your chlorine to work more effectively in the body of the water. So there can be some nice savings associated with the fuel and chemicals. And then the space savings, substantial savings. This is just one example. I mean, we've got many examples with sand. They could be side by side. They could be stacked. It'd be 1 tank, 2 tanks, 3 tanks, 4 tanks. So many different variables with the sand filter. However, this is just one example. It's a 2 tank side by side horizontal fiberglass filter on the left there that's flowing 700 gallons a minute. And it's the area that would be required to house that sand filter. Whereas to the right there, we've got a regenerative media, the Defender filter. That's a 33-inch diameter tank. You can see the substantial space savings. So I found this very beneficial for swim schools because a lot of times, they're going into a unique location, existing building, say. What was the one I just came across recently? I thought it was so cool. It was like an old Outback Steakhouse, right? So the building's already existing there. We're going to make do with what works or what space allotted for it. So the Defender really helps tremendously when it comes to space savings. And the superior water quality, well, that's associated with the perlite media that we use. It's volcanic magma. You can dispose of it direct into sanitary. It doesn't settle like diatomaceous earth, and it doesn't have the waste handling or handling restrictions of diatomaceous earth. It looks very similar. I have it right here. Just a white, very light powder. Comes in 25-pound bags. A 25-pound bag, because it's so light, a 25-pound bag actually looks like a 50-pound bag. Like you see people that aren't aware of what it weighs and they go over and, oh, wait, this is light, right? So that's where we're getting our filtering quality is through this. It's very porous. It holds 300 to 400 times its weight in dirt. And it's not very costly. It only costs about $1 a pound. So it's not a bank breaker. The system's controlled by our RMF controller. It's very intuitive. I mean, we've literally had our finance team come down to our shop and, say to the young lady here, change the media. I mean, she's never operated a pool in her life, right? And she's able to do so because of the instructions that are right there on the screen. The controller actually makes you, confirm, like, yes, I just opened the, effluent valve. Yes, I just opened the drain valve. So very intuitive. A lot of data logging, maintenance reminders, remote connectivity. It is an ANEMA 4X enclosure, so these defenders could literally be installed outdoors. We have quite a few of them in states like Florida that are just installed outdoors. There are some considerations that we need to take if you're installing it outdoors. The compressor, for example, that's providing the air, compressors can't be placed outdoors, so they do need to be under a shelter, but they can also be very remote from the filter, with just air lines going to and from. And the vacuum that's on the side of the filter needs to be protected, but we can put a simple shield over that as well. As far as operation and maintenance is concerned, we talked a little bit about the the media change, but when do you change the media? Primarily based on pressure differential. Just like a sand filter, you backwash a sand filter when your pressure differential increases 10 psi greater than your startup. Same thing with the defender. When your pressure differential increases 10 to 12 greater than your startup, it means the media is expired. It's time to change it. So what does that mean? If we start with a PSI of just 1 pound differential, when that becomes 11 to 13 differential, now we need to change that media. Or it could be by visual inspection. There are some areas of the country that are very high in iron. First state that's coming to mind is Minnesota. So the defender can actually filter out a lot of that, that iron, and you'll see the white perlite start to turn tan or brown, but the pressure differential doesn't build very quickly because it's so fine. So on those installations, sometimes we're changing it just based on the visual inspection of the perlite media. They're still getting the same filter cycles, 3-4 more weeks, but they're just not building the pressure differential. They're more seeing discoloration in the media. And the reason that we do it based on that is because when they were waiting for the media to increase in pressure differential, but what they found was that some of the iron was starting to get past the filter, so and causing more issues down the line with, say, the heater or the UV. So just it really is, your system. It comes down to knowing your system. You become one with it, right? Don't want to sound crazy or anything. But it's like my car. I jump in my car. I know when it's not feeling well. I know when something's off. Same thing you'll find with your Defender filter. You'll be able to predict, okay, I'm going to need to change the media next week. Okay, I'm going to have to do a filter cleanse quarterly or whatever it might be. So get back to the media changes here. Again, pressure differential or visual inspection. Frequency. Outdoor pools, typically every 3 to 4 weeks. Indoor pools, every 1 to 3 months. I'm pretty confident to say that the swim schools are changing the media about every 3 to 4 weeks. But when I look at like a 50-meter indoor pool that, a couple hundred people are in it a week, they could be going 6 months without having to change the media. So it all boils down to bather load. So if you got to change your media, as long as the system's designed appropriately, and what I mean by that is your turnover is correct, your filter rate is correct. If you got to change your media more often, well, then it means you're pushing kids through that pool, and congratulations, you got a good business going, right? How long does it take to change the media? Put 30 to 45 minutes here per defender. I think that's being generous. I would honestly say it'd probably take you about 25 minutes. So once a month, not very often. That doesn't mean we don't want you in your mechanical room every day, right? We still got other things to do there, but you shouldn't have to change the media, but about once a month, and it'd take about 30 minutes, call it. Tube wash chemical cleanse. We have this viewing window here on the front. It's a 12-inch flange that we can unbolt and actually reach in there to wash the flex tubes down. We recommend doing this at least once a year. But it depends on bather load and contaminants, what we're filtering out. On a swim school, I would say that you might need to change, or might need to do a flex tube wash down and a cleaning as often as once a quarter. And that's just to degrease those flex tubes and keep them, fresh and clean and like they're brand new. So we recommend it at least once a year, but want to be transparent. It could be required about up to quarterly. So how do you know when you need this tube wash chem clean? I think we'll get to it on a couple slides here, but you'll start to see a difference. One major difference is your pressure differential will start at a higher differential. So when you go to change your media one day, you've been operating, let's say, for a year, and you go to change your media and you start it back up. Well, rather than the 1 PSI differential, you're seeing a 4 or 5 pound differential. That just means the flex tubes are contaminated. They need to be degreased or washed down following the next media change. It's not something you need to stop everything right now and do. It's just know the next time you go to do this in 3 to 4 weeks, hey, we should plan to do a flex tube washdown. And then ultimately, as I said, it becomes a well-oiled machine. You're going to be able to predict. You're going to know, hey, we're going to do a flex tube washdown every X, Y, and Z. How long does that take? About 2 to 3 hours per defender. And the reason it takes so long is most of that time is just sitting. We want to vacuum the media in, or excuse me, vacuum the cleaner in, pre-coat it in the filter for 2 minutes. And then we're going to put the system in maintenance mode. And what maintenance mode is it's automatically going to bump every 15 minutes, kind of like a washer machine, just to agitate the water within the tank and the cleaner within the tank to make sure we're degreasing, we're washing those flex tubes nicely. So we recommend doing that for at least 1 hour, no more than 2 hours. So that's where the majority of the time is. Other than that, it's 10 minutes vacuuming it in, and then 10 minutes getting the system back up and running when it's all done. So when to bump, we touched on a lot of this already, but we want to bump at least once a day. As I mentioned, I'd recommend considering bumping at night when you shut down, and then in the morning when you right before you open up. No water sent to waste. It doesn't cost anything. You're just redistributing, getting that filter medium all repositioned and ready for another day. We want to definitely bump if the pressure differential increases, up to 10. We want to bump. When it's heavily loaded, visual inspection, again, you'll get a sense. You can feel it. The system will automatically bump if the pressure differential reaches 15. So there's really there's a fail safe there. And again, we touched on when changing the media every 3 to 4 weeks on outdoor and 1 to 3 months on an indoor pool. So here's a sign of, when do you need to do chemical cleaning? It's really contingent on the bather load, as we said. More oils and contaminants equals more cleaning, and that's why I say it's more frequent in a swim school. We look at who our bathers are, right? And let's be honest, are they showering before they get in the pool? I know we all try to, but let's be realistic. But you'd be amazed at how much your performance and operations improves if everybody would just walk through a shower for 15 seconds. I mean, it's unbelievable. Want to do it at least one time a year, but again, might be more frequently for swim schools. Some place like Kalahari Resorts, Great Wolf Lodge, those places, they do the chem cleaning once a month. Do they need to? No, they just it's part of their procedure. Some indicators, we talked about the last one there, an increased normal initial pressure differential. If you typically come in and you put new media in it, it's 1 PSI differential, and then all of a sudden you start doing it, it's 4. That's a telltale sign. Or it could be uneven media coating on the flex tubes. You look through the viewing window and you see some bare spots. Now, it's not uncommon to see a bare spot every here and there. That's not an issue as long as, you're going to bump it tomorrow and that bare spot's going to, disappear or move somewhere else. But if you kind of see like on the left here, that's even drain there, but you can see all the media and we'll call it scum, kind of a scum line all up and down those flex tubes compared to the picture on the right following a chem cleaning. So if the influential pressure builds within 1 hour of media change, or if the filter won't pre-coat properly, uneven media coating. So just a couple telltale signs that, it's time to freshen up those flex tubes. And they really, they get back to brand new condition. Now I want to talk a little bit about the importance of preventative maintenance. That picture on the right says 1,000 words, right? That just didn't get like that overnight. That was obviously a small leak to start with, probably a loose flange that somebody could have easily gone there and, tightened it up and would not be where they're at in that picture. So early identification, I think I mentioned it earlier in this call, is, address issues as they arise. They're only going to compound, they're only going to snowball. So be proactive with scheduling service and making repairs. A lot of it can be done by you or your operator, but as they become more complex, hire a qualified technician. Perfect example is UV systems, right? Those are high electrical. Cabinets. So don't want inexperienced people playing around and risking their safety. Some more preventive maintenance is knowing your system. Have a schematic, a layout of your plans. When you had your pool built, there were a set of plans. Have them handy, and go around and label all your valves and your piping, so you know where the suction side is, you know where the return is, you know where the isolation valves, the shut-off valves. Just buy some little tags off Amazon and go nuts with a marker in your mechanical room, because it'll make it a lot easier. I mean, let's be honest, we all have turnover. So the easier, I mean, you can see in this picture here, UV, oops, wrong way. UV competition. I mean, they know which system this UV is for, but you can see other arrows on the piping and stuff. So encourage you to take the time and go around and really identify everything in your room. It'll pay dividends in the future. Have your O&M manuals handy. Have your preventative maintenance procedures spelled out. There's perfect time to start, right? The first of the year. Sit down and get a calendar out and put a plan together of what you're going to do over the next 12 months. Oh, in May, we're going to do this. In June, we're going to do that. It's all about planning and being preventative, and maintain records and review that data regularly, because you will typically see that something's wrong by reviewing your records and your data than you will with your eyes standing by the side of your pool. Your potential issue is going to arise first in the data that you record. When it gets to the point that your patrons are seeing it, it's too far, right? But if we can head that off ahead of time, the less the patrons see, the better. They just need clean, efficient operation, right? Some tips for preventative maintenance on both sand filters and Defender. Monitor on sand filters, monitor your pressure readings, and most importantly, ensure a sufficient backwash. You want to make sure that, I said this before, you want to make sure that you're backwashing higher than your filter rate. And now it's typically pretty easy, because when we go into backwash, there's less head restriction. So your pump's got, greater capacity to flow in backwash than it does in filter mode. The rule of thumb, honestly, I might come across as a foreign language, but you have a filter rate, right? Your gallons per minute per square foot of filter area. So let's say we're filtering at a rate of 12 GPM per square foot of filter area. The rule of thumb is you want to backwash 3 GPM per square foot greater than your filter rate. So if you're filtering at 12, backwash at 15. But if you're filtering at 15, this is the common mistake that I see, is because some states, majority of states, will allow you to operate up to 15 GPM per square foot. So that's what people size their filter at. And so they're operating at 15. Well, then it's also standard backwash at 15. That's kind of like the industry norm. However, if you're filtering at 15, you need, backwashing at the same rate is not adequate. You want to backwash. If you're filtering at 15, you should be backwashing at 18. These filters, the sand filters, are NSF listed to 20 gallons a minute per square foot. So you don't ever want to flow more than 20 GPM per square foot of filter area. We want to inspect the sand bed. I recommend replacing the top few inches every year. Open up your manway, make sure you got a spare spare gasket there, replacement gasket for when you go to seal that filter, you don't have any issues. But remove that manway and scrape away the first couple inches of sand. Hold it. Does it still feel like it's got sharp edges? Right? Sand shouldn't be perfectly round. It gets round as we backwash it. But silica sand should have sharp edges. That's what's collecting the dirt and debris as it flows through the sand bed. So make sure, the top couple inches look like that. But it's not very costly or hard just to remove a couple inches and replace that every year. But if you start to remove 2 or 3 inches and then you get down and the media is still, maybe it's time for a media change. Media typically lasts 7 to 10 years. 7 to 10 years goes by pretty quick. But just to give you some idea, conduct a filter cleanse. Fill up the tank with some filter cleaner, fill it up with some water and let it soak. That can be very beneficial. And ensure the valves are working properly. Make sure the flanges are tight, the handles are on good, and that they're opening and closing appropriately. If they're getting snagged up, it could be a number of different things. Maybe somebody didn't bevel the inside of the pipe when they installed it. Maybe it's settled and the pipe's cockeyed a little bit and the disc is interfering when you open and close it. Again, don't let things fester. Just kind of, feel and move things periodically and make sure they're working appropriately. And if not, address it. Regenerative media filters, again, monitor the gauges, media visually, change the media when you need to. Do the flex tube wash down, do a filter cleanse. When you go to do the flex tube wash down, make sure you got a spare manway gasket. So again, that we're sealing the tank when we're ready to get back into it. And also a valve and actuator inspection, just like a sand filter. We want to make sure those valves are open and smoothly and effectively and not getting hung up. Some tips on hair and lint strainers. Again, this gets installed before the pump, to protect the pump impeller. But we got to make sure that we're staying on top of them and we're keeping them clean. They're easy to forget. A lot of knobs to unloosen and tighten back up. But we got to ensure that they're not clogged because they will certainly reduce the pump performance and flow. And they should be checked at least daily and potentially cleaned daily. Unlike these hair and lint strainers up here, our stainless steel and our fiberglass, we always provide it with a spare basket. So shut the pump down, take the dirty basket out, put the clean one in, get going again. It's a lot easier to clean those hair and lint strainers when the dirt and debris dries off versus trying to clean it when it's still wet. So a lot easier just to take the dirty one out, put it to the side, let it rest and dry out so you can clean it more effectively. A wire brush works very well for cleaning those, like a welding brush, a nice wire brush. Or honestly, probably not the safest way in the world, but a propane torch works really good too to burn that hair and lint off of those strainer bodies. It's very stinky though. So preventative maintenance, you want to make sure that the welds are all intact on these baskets. If you don't clean the baskets regularly, I almost guarantee that's where you're going to have a failure first is on these baskets, the welds, just because of the vacuum that's being created from a basket that's not being cleaned regularly enough. Check the lid gasket. Always have spare gaskets on hand, right? Whether it's a filter gasket, strainer gasket. Make sure these hold down knobs aren't cracked. Replace them as necessary. Pumps, not too much you can do, preventative maintenance wise. Make sure, a lot of people will have a spare pump sitting on the shelf, which is great, but realize that when a pump sits for a year or longer, you're not likely, you might as well just go ahead and replace all the seals. And if it's, if you shut down and your pump's not epoxy coated, you're probably going to get a, return of some brown water when you first start it up again. But make sure it's got influent and effluent gauges on the influent side, and on the effluent side, a vacuum gauge on the influent, pressure on the right, so that we can always get some readings there. And it's nice to use those pressure gauges to confirm your flow with your pump curve. Actually deadhead the pump, see what kind of reading you get, and go back to your pump curve so you can actually verify your flow. Flow meters are not that honest, right? We can make them read whatever we want them to. The only way to confirm your flow is off the pump curve and the pressure gauges that you're reading at your installation. Preventive maintenance for UV. It should be installed in a bypass loop. You don't want it on the main return line, and that's because they need to be serviced on an annual basis, even twice a year. And these technicians don't want to come in at 3 o'clock in the morning when you're shut down, and you don't want them servicing them at 3 o'clock in the afternoon when you're booming, right? So the way to get around that is install it in a bypass loop so the technicians can come in, service your UV, not disrupt your operation, and they can get to work normal hours. That's really why a bypass is needed. Routine maintenance includes cleaning the quartz components, the glass around the lamp, replacing seals and gaskets, the wiper blade, that sort of thing. Inspect and replace a sacrificial anode. We do install a sacrificial anode in our UV. And just being proactive on the service will ensure the best performance, and that's true. I could also offer up that I'm confident that we've got the best network of partners for UV across the country. Very capable individuals. And we highly recommend you have a service contract with them. And they're not expensive, but they'll come in, a couple $1,000s a year. They'll come in twice a year and replace these components, these consumables, we'll call it. Make sure the system's calibrated, make sure it's running at its optimum performance, make sure it's doing what it should do, so you're not just throwing money at it. But what we do when you sign up for those agreements is we extend the warranty from 1 year to 5 years. So we're very confident in the unit that it's going to deliver many years of performance and benefits for you, but we want to make sure that that it is maintained. And that brings us into our UV. Defender will only improve the UV performance, but wanted to introduce you just a couple aspects of UV to be aware of. There's a lot of it's kind of a wild west out there when it comes to UV with some in some cases, not a good understanding of the difference between low and medium pressure. So hopefully I can clarify a little bit of that for you guys today. Two functions for UV, disinfection and chloramine reduction. It's referred to as secondary disinfection because you can't walk up to the pool, the side of a pool and test for UV, right? There's no residual with UV. That's why it's secondary. Your primary disinfection is your chlorine, your bromine, that is going to have a residual in the pool. And this is just a side note. It's important when you have UV that all you do for your chemical levels is maintain state minimums. What's the state minimum? Is it 1 part per million, 1.5 part per million? Because otherwise the UV is just going to start burning it if you have a good UV system. So it's a lot harder than that, but we want to make sure that the UV is only producing the amount of energy that's required. And we want to make sure that we're not trying to pump too much chlorine in the pool, because then we're throwing money away. So it's a science. It's not hard. It's all taken into consideration when your pool is sized. But when people try to maintain a 5 part per million of chlorine and they've got UV, they're going to realize that they're burning through quite a bit of chlorine and unnecessarily. So the two functions, disinfection complements, again, the primary chemical program, reduces the demand and usage, and inactivates pathogens such as chlorine-resistant Cryptosporidium. So very, very good at disinfectant. Our wafer UV is actually third-party validated, so it's not just me spewing these results. It's a third-party engineering testing firm that has validated that the wafer UV has 3 log removal on Cryptosporidium. So I'll mention what that means, because some people don't know what 3 log refers to. Well, every log refers to a 9. So 3 log removal is 99.9% effective. If it was 4 log, it'd be 99.99%. So with our UV, we're 99.9% effective against cryptosporidium. So, and again, that's not just me spewing that, that's validated and tested. Another great benefit, particularly for swim schools, because majority of them are indoors, is that chloramine reduction. Chlorine reacts with the organic compounds in water. So we've got organics in the pool, the chlorine's going to destroy that. Well, the off-gassing is the chloramines. Forms disinfection byproducts, chloramines. It's off-gassing, it's right at the pool surface. Very heavy, what leads to swimmer asthma, burning eyes, etc. When you can walk into a hotel and smell your way to the pool, right? Those are all chloramines. And they're very corrosive to your indoor environment. So it's important to note that the medium pressure is what combats that. But so what is UV? It's the wavelengths of 100 to 400 nanometers on the UV spectrum, and it inactivates the DNA, the RNA of organisms. Almost, it sterilizes them, right? It doesn't kill them. It just renders them non-productive. Bacteria, germs don't live very long, but they're constantly reproducing. Well, if we can sterilize them so they can no longer reproduce, we're effectively eliminating them. And that's how UV works. The organism dies shortly after we render it non-viable. And the performance is dependent on transmittance. So UVT, that's the percentage of light that travels through a column of water. So the dirtier your water, well, then the less efficient the UV can be. And obviously with a Defender, cleaner water, you get better UV. Let's be honest, swimming pools are communal baths, right? They're not drinking water. So it's important to recognize that, because there's many manufacturers out there that are sizing their UV based on 98% UVT. Well, that's drinking water quality, 98% UVT. Swimming pools are more like 95% UVT, right? There's more contaminants in it. We size our UV at 94% UVT. So we're taking into consideration that we're not swimming in drinking water. We're swimming in a pool that's a communal bath. And we need to take that into account when we're sizing our UV so that it can be more effective no matter what the water quality is. And, so we might even take that into account if we're doing a spray ground, say, an outdoor spray ground that's got no standing water, it's just got a holding tank underground. Well, that's essentially a parking lot wash, right? So their UVT is more like 92%. So we'll size the UV appropriately. Just need to know the application and, is it indoor versus outdoor, etc. So low versus medium pressure. It's the pressure of mercury gas inside the UV lamp. We're producing wavelengths in the 200 to 280 nanometers, the UVC spectrum. You can see there on the right. So what's the difference between low and medium? Well, low pressure is monochromatic. It only emits a single 254 nanometer energy wavelength. So it's breaking down monochloramines. Whereas medium pressure is polychromatic. It emits energy wavelengths across the entire UVC spectrum. So we're demonstrating higher germicidal disinfectancy efficiencies, and we're breaking down all three chloramine species. So it's just more broad wavelength produced by the medium pressure than the low pressure. The low pressure is just focused on that single wavelength. Some special considerations to consider when selecting EUV is, you want to have a dose readout. You want to be able to see, and I have a feeling that NSF is going to be requiring this shortly. It's going to require a readout on UVs, or I hope that they do, because otherwise you just got a blue light in the tube, right? And you're paying for electricity. We want to make sure that the UV is producing the amount of energy that's needed to combat whatever we're concerned with. If it's germicidal, then we want to make sure we're at least 40 milliamps. And outdoor is, or excuse me, the chloramine destruction is 60. So we want to make sure that we're producing enough energy in that UV lamp to destroy, the chloramines if it's an indoor pool. So we want to be at 60. We don't want to be at 198, full power, because then we're just burning up chlorine, right? We need to be at 40 for germicidal and 60 for chloramines. Automatic wiper for the quart sleeve. That's very important because as dirt and debris, as particulate travels through that lamp, it can get baked onto the quart sleeve, and then that's going to render the lamp inefficient, right? It's kind of going back to that UVT. We need to make sure that it's nice and clean for the light to penetrate the water flowing through it. So wiper on the quart sleeve that will schedule to go up and down the quart sleeve based on whatever your turnover is. So if you got a 2-hour turnover, if you turn your pool over every 2 hours, that wiper will run up and down that quart sleeve to keep it clean. And that automatic wiper also wipes that sensor, which is this black piece at the top. That's what's going to, calculate the amount of energy that we're producing at any given time. Already mentioned that ours is third-party validated. It's NSF listed, etc. And I also did mention that we've got the best support network across the country to make sure that they're working as they were designed to be. That's what's most important. A little close up of the wafer UV. Very easy maintenance and access from one side of it. Again, third-party validated, short and compact. I mean, not many people on this call will probably ever need a 12-inch unit, but a 12-inch unit is less than 8 inches flange to flange. So we're talking that's why it's called the wafer. It's like a wafer valve. And it's got a lot of patented information, the compact pulse lock wiper for simple maintenance and calibration there on the left. And the twist locks there. When we unscrew this twist lock, automatically cuts the power off to the unit. So safety is always first and foremost in mind. Wrapping up here, guys. See the time's disappearing real fast. Wanted to introduce you to our support. This is my team for North America. Sales and support. We got Arnie up in the northwest. We've got Steve down in the southwest. Brian Randisi in the center part of the country. We got Sherry up in the northeast, mid-Atlantic states, and Carrie down in the southeast. And they're all supported by inside sales and project management and also estimating. And the reason we do this is because we want to, we got a lot of repeat customers, right? It's, swim schools, a lot of people own multiple sites or even contractors that we work with. So we're really just trying to encourage and embody the relationships, right? The being able to know who to reach out to. So feel free to reach out to any of these individuals based on your locale. And if all else fails, please feel free to reach out to me. And then lastly is our center of excellence, post installation support. This is right back here in Warwick, Rhode Island. We typically have about one training a month. We actually have one going on this week. But this gives very, nice hands-on learning experience with the Defender and our wafer UV. This is mostly, contractors that are coming here for this, that are, our feet on the street that are supporting our installations. But we'll also do it, we can do this remotely. So if you want to do a remote training, or we can even schedule to come to your site. I can say for once, for example, we did a swim school that's part of your organization that has multiple installations. So we went out to one of their sites and all their operators came from around their different installations and, spent a half a day, taking a Defender part and getting, better acquainted with it. So we want to make sure that you guys are supported is, I guess, what I'm trying to say in short. With that, I'd be happy to answer any questions that you might have. I love this picture here. We don't do just swimming pools. We also do zoos and aquariums, and we figure if if the water's good enough to keep these fish alive, I think it's good enough for your kids to swim in, right?
Thanks so much, Scott. That was really great. I just wanted to let you know there was a question that came in, so I wanted to let you know about that. Somebody had written, you mentioned Neptune Benson has a center of excellence. How do I go about signing up for a training class? And is there a service and support, excuse me, and is there service and support offered internationally as well?
Yeah. So our center of excellence, the way we schedule it is reach out to, this the list of individuals. I was going to see if I could go back there in case anybody wanted to jot any emails or phone numbers down. But so Arnie, Brian, Carrie, myself, Sherry, or Steve will take the calls in from our respective territories and then put them in and find out, really try to accommodate your needs. I mean, when you plan on coming, how many people you plan on sending, and then trying to coordinate a day and time from then. And again, we can also do it remotely. The Center of Excellence is awesome though, because, it's hands-on, but we can do it remotely, or we could also come out to an existing installation if that's the case. As far as the international aspect, we are a global company. You saw on the map the number of installations. There are other teams just like mine all around the world. So the APAC region, EMAU, Australia, Europe. I can't say they're as good as my team, but they're out there.
Fair enough. Thanks so much, Scott. I don't
Thank
see
you.
any other questions that have come in, but I know obviously it's great for folks to have contact information. So anything that comes up between now and later, they'll have a point of contact to reach out. Obviously, they can always contact the office as well, and we're happy to to connect folks. So again, I know we're just about out of time here, so we'll wrap it up. But Scott, thank you so much, and thanks to
Well,
the whole
thank you.
team at Neptune Benson. We really appreciate our partnership with you guys and all you do for our members. So with that, we'll end things, but happy holidays, everybody, and thanks again.
Yes, thank you, Ann. Happy holidays to you guys. We'll talk soon.
Thanks. Take care. Bye-bye.
Bye-bye.